Exercise 11.1 Problem 10 Solution. The time in seconds taken by a group of people to walk across a pedestrian crossing is given in the table. Okay, calculate the variance and standard deviation. Okay, so we need to calculate the variance and standard deviation. The time in seconds, okay, is given, taken by a group of people. Okay, is given in this table. So the number of people, which means this is the frequency, right? Wherever there is number involved, that becomes a frequency, and the other one is basically the x value, okay, the time in seconds. The only difference which you have to see here is, earlier we were given specific value like 10, 7, 4, 3, etc., etc. Here they are giving it as a range. They are giving it in a class interval. Okay, this is known as a class interval. So suppose a person takes 7 seconds, he will fall into this class and it will get counted here. 7 or 8 or 9 or whatever it is. So whenever we have large group of data, we'll have to use class intervals to group them into some logical intervals. Otherwise, the table will be having too many x values, right? And it will be very difficult and tedious to calculate the standard deviation and variance in such cases. Okay, so that is why this class interval is used. Now, the only difference is here we'll have to x is though I have told this is x, but this is exactly not x. The mid value of this interval is the class. Is the x actually. So mid value is 5 plus 10, 15. 15 divided by 2, 7.5 here, and this will be 10 plus 15, 27. 27 divided by 2, that is 12.5, right? 10 plus 15, 25, 25 divided by 2, that is 12.5. So this will be 17.5, 22.5 here, and 27.5. So these will be the mid values of the class intervals, and they become the x. Okay, and here we will be using, though it might not be really applicable in this case, we will use the step deviation method. So step deviation method, the formula is the same exactly as you do for assumed mean. Only thing is that we'll have to multiply it by a common factor, c square. C is the common factor, which I'll explain a little later. And the d, the deviation, earlier it used to be x minus a. Here it is x minus a by c. Okay, so let's see the table. The table is exactly the previous one. Only thing is that here we get an additional column, and here we are getting a divisor, extra divisor, which is a common factor. So though it might not be exactly applicable in this case, I have started doing step deviation method for you to introduce it, because we have only few more problems to do. The key is, whenever this x minus a is very big, okay, but may not be in this case. Some cases it will be 100, 200, 300, etc., etc. And when they have a common factor, so here you can see the common factor is 5. In which case we can divide that, and then all our multiplication fd and fd square will be smaller. Otherwise it will become bigger. So and that is the reason of using this step deviation method. And since we are dividing it by a common factor, the final standard deviation also needs to be multiplied, because in this case is variance, it is c square. If it is standard deviation, it is to be multiplied by c. Okay, so that is the key here, and that's the only difference. Okay, so otherwise everything is the same. Okay, this is another column, new column from assumed mean method, because we are not having x value exactly. It is a midpoint of this class intervals. So 5 and 10 is the difference is 5, right? That divided by 2, that is 2.5. So 2.5 you have to add to all the lower limits. You will get the mid value. So 5 plus 2.5, 7.5. 10 plus 2.5, 12.5. 15 plus 2.5, 17.5. Like that you get these remaining values. Now frequency, we are getting the corresponding values here from this table and writing it down here. And out of these values, which is a mid value? 17.5 is the mid value. So let's assume that to be the mean. So a is 17.5. So find x minus a, that is x minus 17.5. So 7.5 minus 10, that is minus 10. 12.5 minus 10 minus 12.7.5 minus 17.5, that is minus 10. 12.5 minus 17.5, which is a, right? That is minus 5. 17.5 minus 17.5, that is 0. 22.5 minus 17.5, that is 5. 27.5 minus 17.5, that is 10. So we have all the x minus a calculated. Now we go to the next method, next column, where deviation d is calculated, but only the difference is that we find the common factor and divide the whole thing by the common factor. The common factor for all these numbers is 5. So we will divide each and every number by 5. So c is the common factor, that is taken as 5. You have to remember this c, because that c will get multiplied. Finally will multiply, it will get involved in the formula, right? So you have to remember this c. So c is taken as 5. So d is x minus a divided by c. So x minus a we have already calculated. So this column needs to be divided by 5. So minus 10 divided by 5 is minus 2. Minus 5 divided by 5 is a minus 1. 0 by 5 is 0. 5 by 5 is 1. 10 by 5 is 2. Then the rest is the same. FD will have to calculate. 4 into minus 2, minus 8. 8 into minus 1 is minus 8. Do the same for the remaining 3 values. You will get the FD values. Then FD square. So we have D square. D here. D square is 4. 4 into 4, 16. Minus 1. Minus 1 square is 1. 1 into 8 is 8. Okay. 0 square into 15 is 0. 1 into 1 square is 1. 1 into 12 is 12. They're doing the same. We get 44 for this row. Now we have got all the values. So sum up all your FD squares, sum up your FD, sum up all your F values, and substitute in this formula. See here, FD square we know sigma F we know, sigma FD we know, C we know. C is a common factor which we have taken as 5, right? So we know all the values. All we need to do is substitute these values in this formula, simplify and get the variance. Once you get the variance, the standard deviation is square root of the variance. Okay. So let me sum up. The only difference is that you'll have to find mid value is the x taken, and you have to take the mid value of the range of the various values of the mid values as an assumed mean, and you have to divide all the x minus a by a common factor. Okay, so these are the things which are new in this problem, and this method is known as a step deviation method. And when this method is used, it is used when we have bigger values and you have a common factor among the x minus a's. This in this case is 5 is a common factor. So you can divide it, which means our FD and FD square becomes smaller values. Otherwise let's assume, so this will be minus 10, 10 square will be 100, 100 into 4, 400. So you'll be getting bigger numbers over here. So for that only we are doing this common factor division. Okay. Right, now let's go into the final calculation. We are applying the formula and we have all the values here. Okay, sigma f is 50, sigma fd is 18, sigma fd square is 80. So substituting all these things, sigma fd square is 80, sigma f is 50, fd is 18, and sigma f is 50 into c square. C is 5, right? So that becomes 5 square. Now you simplify. This is 80 by 50. This will be 18 square, 324. 50 square is 2500. So you take LCM of 2500. So this becomes 50 will go 50 times. 50 into 80 is 80 into 50. And this will come as it is. So this is 4000 minus 324 divided by 2500. And the 5 square becomes 25. So when you subtract this, this becomes 3676 divided by 2500 into 25. 25 will go here 100 times. Okay. Okay, sorry about my writing. With this, the best I can do with this pad. Okay, so 100 means then this will become 36.76. So our variance is 36.76 and standard deviation is square root of variance, that is square root of 36.76, which is 6.06. How will you calculate this? You take the log of 36.76, divide it by 2 and then take anti-log. Okay, and that's all in this problem. I hope it's clear. If not, please go through one more time. It will become clear. Thanks for watching this video.